Welcome everybody to our first YouTube live event from Subsurface Solutions on line locators, and we're going to be training today on the 7100 from Radiodetection. And if you're here, that's because you have a common interest in keeping everybody safe out there. And 1 out of every 1,000 locates that go out the door, there is a damage. Every 60 seconds there's a damage out there, and so the fact that you're here means you're trying to make a difference, just like we are, providing free training to our customers. And today it's going to be unique because we're going to have live cameras set up outside so we can emulate the hands-on training we usually give our customers face-to-face in the field. With this day and age, we're trying to come up with an alternative way of getting the message out to you, educating you on line locators. And so we'll move back and forth between the inside and the outside. And if you have comments, the nice thing about YouTube is you can comment off to the left or the right, or depending on what device you're running. We'll put the live chat area down below on your phone or off to the right or the left on your computer. And if you've got questions, we'll try to answer them in the comment area or live on the air, and do our best to interact with you back and forth. We are going to be going over the 7100, which has several different models, but we're going to be concentrating on these three right here: the DL, the PL, the TL. The DL is the basic entry locator. All three of them are built just like the 8100. They have the exactitude, all the antennas, the filtering, and everything to locate just as far, just as deep as the 8100. These are just the simplified versions because they don't have the GPS mapping capabilities and the remote control capabilities over the transmitter, along with all the different plethora of frequencies that you get with the 81. So the DL is the basic model. Comes with 5 frequencies. It has power mode. It has radio mode for passive frequencies. It has CPS mode for locating cathodically protected gas lines. It's the one we sell the most of. It's a good entry-level locator for anybody. And then the PL, same locator. It adds fault find capabilities, and it adds power filters. So if you do a lot of power locating, especially passive locating on power mode, that will hone in on different filters. And then the TL is for telephone. When you have any kind of resistant lines you're trying to locate, it gives you a couple higher frequencies like you see down there that allow you to push your signal to the end of the line. But by the time you're done here, you'll know what's in your kit. How does a locator work? We'll cover the basics on how locators work in general, what's the science behind them, and then how to set up your transmitter, how to set up your receiver, how to work them properly. How do you confirm your locate for accuracy using the tools that you see in the receiver, the depth reading, the current measurement, and the peak and the null arrows, and then what accessories you need on your locator and how to care for your locator correctly. And so what's in your locator kit? You got a receiver, you got your transmitter, you got your 20-foot long cables, a ground rod, your yellow extension, 30-foot extra extension spool, a magnet, ring clamp, and maybe some other accessories like an A-frame. And then you picked either a carry bag or a hard case. You can also get a backpack that's new from Radiodetection to carry all that stuff in as well. So let's get down to the nuts and bolts. How does a locator work? How do locators work? Well, you've probably seen this guy before. He's probably in your family, maybe. This is my Uncle Jimmy. Everybody has one like him that says, hey, I can find that for you. Let me get my witching sticks out. And so they pull out two rods and they start searching for the line, moving around aimlessly, and all of a sudden they move and they go different directions, and I found it, and they are working to a point. But they don't put a lot of faith into witching sticks. If you've tried it before, which I know you have, everybody has tried it before, just hold the rods out away from your body and perpendicular to the line that you're going to be crossing. And when you cross over it, they're going to want to go parallel. They're going to want to magnetize to it. That's how witching sticks work. They're picking up the magnetic field, so to speak, and it might not be just on the cable. It might be the Earth's magnetic field, and there's a change in it where there was an open trench. But witching sticks do work. They just don't work very well. And so we enhance that technology. We add a receiver to it. And as you can see, by putting our own signal on the line, creating a magnetic field with a given frequency, we're able to isolate the line much better, give us a better reading, triangulate it using multiple antennas, give us an automated depth reading, and a compass, arrows that tell us to go left and right, makes everything a lot easier. And so that's what we're going to be talking about today, is the RD7100 series locator by Radiodetection, and we'll go over that pretty thoroughly, but always keep in mind we are using electromagnetism. Electromagnetism, whether you're using witching sticks or using an active locator like that one in the video, you are alternating current. And so you're taking DC current, you're alternating it and moving it at a rate of whatever frequency you choose. And so if you chose 8 kilohertz on the transmitter, you're basically moving it 8,000 times per second. If you take a battery and hook up a wire to it and just turn the battery or turn the wire on and off or disconnect it 1 time per second, it would move a compass. You'd see the compass moving next to it, and that's a 1 hertz frequency, 1 time per second. And so 60 hertz is 60 times per second. And the faster you alternate it, the more excited it gets. The current's moving back and forth, and it agitates the receiver. Basically, the antenna inside the receiver will then pick up that magnetic field, and that's how we know when we're over the top of a line. And so always keep that in mind. We're using electromagnetism. We're locating a magnetic field, not a cable or a pipe. We're locating a magnetic field we're putting onto it. And so wherever we pick up the highest amount of signal, that's when we should be over the top of that cable or pipe. But the advantages to electromagnetism is they will go very deep. They'll go through all different types of soils, and they can go through asphalt and concrete just fine. And we're able to, as long as we have 2 antennas in there, triangulate it. Give us a depth reading, give us a current measurement reading to verify we're on the right line. And so the radio detection unit can go really deep. It can go up to, beyond 50 foot. It can go up to 100 foot deep in some cases. And so it's a very sensitive receiver, a very powerful transmitter. And so when we hook up, that is called active locating. When we're not hooked up and we're just picking up just frequencies that are already out there, like the witching sticks, that's called passive locating. So let's go over that.
Pipe and cable locating, both of which require the pipe or cable to be able to conduct electricity. In other words, they must be metallic. The first method is known as active locating because a transmitter is used to impose the circulation of an electric current on the pipe or cable, and a receiver is used to detect the field created by the current. The second method is known as passive locating because the receiver detects a field created by the current that's already circulating on the cable. No transmitter is required.
I really appreciate Sondes putting those nice training videos together, and I consult to them all the time. Sondes and Radiodetection, basically sister companies, but they do a great job of training, and so I pulled that off of their website. Hopefully I'm all right with that. But hey, the Sondes videos, if you need any more videos on locating, go to our page, Subsurface Solutions. We have our own YouTube page. If you haven't subscribed yet, hit subscribe and go through our different videos. But also Sondes has some good ones in radio detection as well. And so again, this is Subsurface Solutions training. Anything that we say or do here, we're just trying to educate you, pass on our knowledge, but don't hold us accountable for your next bad mislocate. But if you do have questions, we're always here to help. We always want to do training. And so let's talk about directly hooking up active locating, like it was saying in the video. Active locating is the result of hooking up a transmitter with a ground rod. And so you're applying a signal. You're putting a ground rod in the ground and then attaching your red lead to, in this case, the hydrant. You may need to go get through the paint and stuff, so you may need to scrape it a little bit in order for it to work. But then you putting the ground rod into the ground off to the side of the transmitter in an isolated area. And so in this case, we're at 90 degrees. We are putting it 90 degrees from what we're trying to locate, getting it in the direction where we're not going to be waving the wand around. And the longer the ground rod, the better it's going to complete the circuit, because what's happening here is your signal is going down the line and it's slowly dissipating off the line and returning back to the ground rod. And so it needs to be able to complete a circuit to work. If your ground's not good or if the conductor's not good, you're not going to be able to complete a circuit. So that's how it all works. You're just like a light bulb completing a circuit. And so the ground is a conductor as well. So your pipe and cable might be a great conductor, but your ground is where it all starts. So have a good ground rod, put the ground rod deep into the ground, and put it in an isolated area where it's not over the top of another utility line. And this is part of the GASP or grasp method, as how radio detection calls it. And so let's go over the transmitter. Let's go over the storage tray, the battery tray, the buttons, applying the signal. So unzip your bag and take your receiver out, and underneath the receiver you'll find the transmitter, and underneath the transmitter you'll find a hidden storage tray that contains your direct connect leads. Those are 20-foot long leads, red-black leads, and you plug them into the front of the transmitter. But next to those you have your stainless steel ground rod, and you have a 30-foot extension spool. So that extends your ground out further away from the ground, or from the transmitter. You just plug that into the back of your black lead on your direct connect leads, and that will allow you to get up to 50 foot away from your transmitter. And so with that, you also have a magnet that will magnetize up to a streetlight pole or a transmitter or some other utility that doesn't have a good connection to it. So, but underneath the transmitter, you have your battery tray. So just twist the knob there, and you'll see your 8 D-cell batteries, alkaline batteries. And if you need to put your rechargeable pack in, just push in on the hinge, and it unhinges from the top of the transmitter, nice and easy. And you can put the rechargeable in, and then just shut the tray back up. But when you get back into the transmitter, you'll have to change your settings over to lithium ion. So by a push of the on-off key, it will turn the unit on, but to turn it off, you need to hold down on the on-off key for about just a couple seconds is all. But if you fast click it after you turned it on, it goes into a menu. And in that menu, you can control things that you don't use very often, such as the volume level and model of receiver type. But let's change the battery type to lithium ion. So I'll just find battery in the menu, change it to lithium ion by using the up-down arrows, and then toggle back out using the F key, and then we're set to go. So the unit will come right back on when you turn it on to whatever frequency you're using or whatever output settings you were using. But to control the output, you just push up and down with the arrows, and you can see it's up to 50% right now. And the direct connect leads plug right into the front there. Just place the arrow straight up and plug them in, and then the other port is for an accessory AC power supply. And so to shut the unit off, just hold down on the on-off key for a couple seconds, and then it's off. But let's go over active locating and the 3 different types of how to apply your signal actively.
Active locating requires you to create an electrical circuit through which current can flow. This can be accomplished with 3 different types of connections, known as active modes. The 3 active modes of connecting are direct, also known as conductive, inductive clamp, and inductive. The direct mode produces the largest amount of current and increases locating success. The inductive clamp mode produces less current, but it's a good choice when lack of access to the pipe or cable prevents you from using the direct mode. The inductive mode is often referred to as the drop-the-box method, because the transmitter's box is placed on the ground near the pipe or cable to induce the current. It produces far less current than direct or inductive clamp, and should only be used when the other modes are not practical.
Well, thanks Sondes once again for your awesome videos, and I never asked them if I could use the videos, so don't tell them. Hopefully they're all right with this, but they do a good job of how to directly connect, how to apply your signal. Direct connection is number 1. So going over direct connection, that's the best way to apply your signal. But when you do a direct connection, you have to have a good ground. And so the ground rod they give you, let me pull that out here so you can see, it's only so long. They don't make it any longer because theoretically when you put this in the ground, you're supposed to call 811 and call in a locate ticket first. But sometimes that's not long enough for what you need to locate. Sometimes it's not getting down to the good earth, so you find an alternative ground. Make sure it's an isolated ground. Use a stop sign. Use some marking flags. Use a fence, use a culvert, something that has a lot of surface area but isolated, not going over the top of other utilities, and not attached to any other grounding sources. And so make sure maybe a large probe right here, that 3-4 foot long probe would work good as well. So choose a good ground because you need a good return path, and then make sure the ground's not directly over the utility that you are trying to locate. You want it at a 90-degree angle, just like the video said, but again, just get it in an isolated area, because in this picture here, your signal's just probably going right back to the ground. You don't want to make it too easy to get back to the ground rod. You make it a little difficult, so your signal will go down the pipe or the cable that you're trying to locate instead. The other side of things, what do you hook onto? Where do you hook up? Where do you apply your signal? Think of it like putting a puzzle together. You want to work from the outside in. You want to go into the congestion. You don't want to try to work your way out of it. And so hook up to the end of the line, hook up to the meter, or hook up to the end of the pipe or the end of the cable, and get your signal to travel to where the path of least resistance is. That's where electricity wants to go. It wants to go to where the mass is, where the large object is. So it wants to go down the service to the main, not from the main to the service, down the service to the main. It wants to go from the dead end to where it can travel. It wants to go where the path of least resistance is. It's always traveling the path of least resistance. And so Ohm's law is where it all begins. This characterization is pretty darn good. And so you can see here that the resistance, ohms, is trying to give amps no passageway. And so the voltage is what's important here. Volts is pushing the amps in the butt and saying, hey, get through that hole, get down that line. And so don't really worry about watts. Watts is the opening, and resistance is closing that opening. But the volts, it's important to have good voltage in your transmitter to get to push against that resistance. And so all the radio detection units have up to 90 volts. As a default, they go to 30, but they will go up to 90. And so if you just turn your transmitter on, plug your leads together, you're going to see your milliamp reading go up. And in this case, it goes up to 50. You can see you got 50 milliamps, 0 volts. Unplug them, 30 volts, 0 milliamps. Plug them back together, 50 milliamps, 0 volts. So that's what you're looking for. You're looking for your voltage to go down, your milliamps to go up, letting you know you got good continuity, you're applying the signal, everything's working well. And so you just go ahead and test your leads if you have to that way too. Just make sure you got a good connection, and that's letting you know that you're probably ready to go with your transmitter. And so look at your milliamps. Here we got 100 milliamps, 0.19 volts. That's probably a pretty good connection. But again, if you got resistance, you're going to see your voltage go a little higher, but as long as you're getting your milliamps you need, you should be able to get your locate done. So let me show you how this works. Let's go to our mobile camera on outside. Give me a couple moments to get out there with my locator, and I'll show you how to do a direct connect. And so you want to think about, first of all, where you're going to set your ground. Remember, the ground should be 90 degrees away from the direction you plan on locating. And so if I knew this meter here, what I'm going to locate is going that way or this way, I want to get my ground out that way. You don't have to be exactly 90 degrees, because if you go 90 degrees the other direction over there, you're going to be right over the top of the power, so we don't want to do that. And so find a good spot, a remote spot to put your ground rod, and grab my ground rod out of here, and we'll go ahead and I'm going to set it back here. And so I know it's not exactly 90 degrees, but I know it's the opposite direction of where I want to go. And get the ground far into the earth so you get good conductivity, get down to the good earth where your return current's going to get back to it. And then go ahead and plug in your cables. You have your black and your red, just like we just talked about. And normally you'll put them away a little nicer than I do, so they're not all tangled when you take them out of the bag. Plug in your direct connect leads. There's an arrow right there on your direct connect leads that goes directly up, and they should slide right in just like that. So if you trip over them, they'll come out. But go ahead and just plug them in. And then I like to turn the transmitter on before I even hook up the cables, because I like to be able to see the milliamp reading. And so when I get a good connection, I'm going to connect the black lead to my ground rod over here. Then I'm going to connect the red lead to what I'm going to locate. And so we're going to hook up to this tracer wire on the gas and locate out this gas service. So just make sure you got a good connection. You have to maybe get through the paint. If there's no tracer wire, it's just a riser or something, get through the paint. And the way you know you got good continuity is your milliamp reading. I got it turned up all the way right now, so I'm going to turn it down to a couple bars of output. But that's what you want to do. You want to figure out how far do I need to locate. So if I'm only going to locate, you know, maybe 25 or 50 foot, I just need 1 bar of output. Really 10 milliamps is going to do fine for that. But it also depends on what you're locating. If you're locating something non-conductive, you need to maybe turn it up a little bit more. So if I need to go maybe up to 1/4 of a mile, I'll go up to about 50 milliamps. If I need to go a mile, I'm going to maybe go up to 100 milliamps. But you just adjust your output level here by your up-down arrows and kind of see where your current ends up and push out the necessary current for the distance you plan on going. So we have 200 milliamps going out. 512 is our frequency, but if I wanted to use a different one, 512 is the lower frequency, I'm just going to hit the F key and change it. And so I'm just going to go up to 8 kilohertz. Your transmitter may not have all these different frequencies enabled. They can be shut off or turned on if you go into that menu key by hitting the on-off key real quick. We have a whole video on that, but I'm on 8 kilohertz right now. One of the favorites that a lot of people like to use because it's not too low, not too high. Got 100 milliamps going out. I don't need 100 milliamps for this tracer wire. I'm just going to turn it down a little bit and go down to 20 milliamps. And my voltage, you can see right there, my voltage says 1.9 volts. So if I had bad continuity, my voltage would go high, my milliamps would go low. But in this case, my milliamps is higher than my voltage, everything looks good. And so now all we have to do is match up our receiver to that same frequency that the transmitter's saying it is. So I turn my receiver on, and we'll go over the receiver more in a little while, but I match up my frequency on the receiver. Here's my frequencies down here. So I hit the F key until I see 8 kilohertz show up. And again, I'm on peak mode. We'll go over the different antenna modes here in a little bit when we cover the receiver more. But I'll just start walking around. Remember the grasp, you're grounding, then you're worried about milliamps, amps. And now I'm going to scan. And so I'm scanning, doing a nice circle around any direction that this line could be taking off. And right here I'm picking up my highest response, and I pinpointed. So I'm going to go ahead and pinpoint by looking exactly where I peak out. Got a 2-foot depth reading. My milliamp reading, 17 milliamps. We're pushing out 20. That's a good sign that we are definitely over the right line, because if that was much lower, this possibly isn't what we're looking for. So always comparing my milliamps here on my receiver to what my transmitter says it's pushing out. And now I can go ahead and continue on locating. And so that's active locating. So let's go over number 2, the ring clamp really quick.
The inductive clamp method of connection requires you to apply a clamp around the pipe or cable. In some cases, the pipe or cable can be found next to buildings or on utility poles. Sometimes you'll need to dig to expose the line and be able to apply the clamp. It must close fully around the conductor. At least one end, but preferably both ends, the near and far of the pipe or cable, must be well grounded. Without a ground, the current will be extremely low, which will make locating nearly impossible. If only one end can be grounded, it should be the far end. Otherwise, most of the current will quickly flow from the clamp to the near grounded end.
So the ring clamp, it's a great option when you don't have a place to put a ground. It's a good alternative. It's also kind of a shortcut to be able to locate live power lines and such. And it comes in a 2-inch, a 4-inch, a 5.1 inch, or an 8.5 inch from Radiodetection. The very first one is a current direction ring clamp that's used with 8100s to tell you which direction your current's running on the line. But for the most part, the 4-inch ring clamp works for everybody. It's small enough to fit in small pedestals or manholes, but it's big enough to fit around a 3-inch conduit. But if you need to go around 4-inch conduit or 5-inch, you would want the 5.1 inch ring clamp. And so let's go outside and let's show you how to hook up the ring clamp. Give me a moment. So number two, the ring clamp is another way to apply your signal. And like the video said, we want to make sure that the ring clamp's completely closed and put it around what we want to locate. Whatever we're locating with the ring clamp, there needs to be continuity on both sides of it, just like the video says. And so you plug in the ring clamp the same way you plugged in your direct connect leads, and then just place it around what you want to locate. When I turn the unit on here, you're going to see that it's going to say there's a ring clamp enabled. See the little icon there? And there's our output. So we don't get a milliamp reading because you can't really measure it without a direct connection, but I'm just going to go ahead and turn up the ring clamp. And I don't know if you can hear that, but the ring clamp's actually vibrating a little bit, and there's a little bit of a noise coming off of it. When I open it up, the noise goes away because I've separated the contacts here. You got to make sure this middle contact and this middle contact are touching when it's completely closed. So now it's inducing into whatever's inside the ring clamp. It's jumping from the ring clamp to that cable that's inside this conduit, and then we can go ahead and match up our frequency again on the receiver, 8 kilohertz. But a lot of times, if 8's not working, use 33. One of those two should work with a ring clamp, unless it's a really bad conductor, like the end of a streetlight series, if it's the last streetlight on the series, or if it's just a wire not really tied to anything, a small wire maybe that's in a traffic signal. Use 131 or something really high, and then you'll get it to jump across, because you're trying to get the signal to jump from here to whatever's inside the ring clamp. You're purposely trying to bleed it across, and higher frequencies bleed easier. So that's why I like to use 33 kilohertz when I use the ring clamp. Really handy because you don't have to put a ground in the ground. So there's, if there's a big concrete patio here or a parking lot, you don't have to worry about getting the ground rod in between some crack or something and get it grounded out. This doesn't require a ground. It's just go up to the meter, hook around the pipe, and you should be good to go. Just go out there and start doing your grasp, your scanning and then pinpointing with the receiver. So that's the ring clamp. Let's go back inside and go over number 3, induction. So number 3, induction. That's the third way to apply your signal actively, and setting the transmitter over the top of the utility you want to locate. And you just unplug the cables and it will automatically go into induction mode. Just make sure you're relatively close to what you want to locate. The problem with induction is it's hard to isolate exactly your signal on one line, because if there's a neighboring line next to it, it easily transfers over to that as well. So whatever conductor is the path of least resistance, that's where most of your signal is going to want to go. So you can turn your transmitter on its side, use the kickstand on the side of the transmitter to try to point that induction over to where you need it to go and get it to ignore the stuff off to the side. But one thing to keep in mind is always stay 30-40 foot away from your transmitter. Otherwise, all you do is pick up the transmitter signal itself and not the actual pipe or cable underneath. You can do an induction sweep using this. That's easy to do if you have 2 people. You walk together. Once you're over a conductor, your signal will go up on the receiver and you'll be able to tell. It's a good sweep method. Do the 4-way sweep method inductively to be able to tell if there's something down there that's not been located. It's a good safety measure. Let's again go back outside. I'm getting used to running in and out all the time, but give me a second. I'm running out of breath here, but let's go outside and practice the induction method. Okay, so we're back outside and we're going to go over induction mode and how to apply your signal inductively. We've gone over the active, locating, direct hooking up, and the ring clamp. So inductive means you're going to set the transmitter over the top of what you want to locate. We have a power line coming through here, so we'll go ahead and induce a signal. And what's happening through induction is you have a antenna down here inside the transmitter, and as long as that antenna is perpendicular to what you're trying to induce into, it's going to work really well. And the Radiodetection has a really powerful induction transmitter, and so you just unplug the cables from the transmitter and turn the unit on, and as long as there's no cables plugged in, you're going to see the output level here be in a percentage and not milliamps. And so you just adjust your output to where you want to go, and a lot of times for induction I just go ahead and turn it up to 100%. And since we're trying to push signal into the line or bleed it over, you're going to be having to compensate for what you're going to lose in the open air, and so the deeper that line is, the harder it's going to be to induce into. But normally, you know, stuff is around 4 or 5 foot deep, and usually it's pretty easy to induce into that. But for pipe that's 10, 12 foot deep, you're getting kind of at the limitations of what you can and do inductively. And so we're going to turn the output up to 100%, and then we're going to have to use a higher frequency. You're going to notice you can't go to the low frequencies, the 512 hertz. You can only go to 940 hertz and up when you're in induction mode. And so on the 7100 series locator, we are normally going to go to either 8 kilohertz or 33, 65, or if you have it in your receiver, go to 83 kilohertz. Some receivers also have the 131, like the TL has the 131, but inductively you want to try to stay around 33 kilohertz, because every time you go a little higher in your frequency, you're going to get less distance on your locate. It may jump across over to what you're trying to induce into better, but it won't give you as much distance, as much power once it finally gets on there. So if you can get 8 to work, that really works really well, as long as you can get it to jump across into the conductor. But we'll go to 33 for this example, and you can see there's a little animation going down underneath the output level, and it's showing us it's throwing signal underneath the box, and we just want the handle going the same direction as the cable or pipe we're trying to induce into. So I know there's a cable right in here because we've power moded it before, but I'm going to set the transmitter down like that, and so it's the same direction as the cable. I can also set it like that. Either way, you just want to make sure you have it close to the line. It can be a little off to the side if you don't know exactly where it's at, but I'm going to now match up my frequency on the receiver to also 33. So I just hit the F key for frequency, just like I did on the transmitter, and go to 33. And for induction, I like to use peak mode of the hill icon over here and just look for my highest response. But it's important that you get away from the transmitter, because you can see the transmitter is throwing out a lot of signal, and if you're too close, all you're going to do is pick up the transmitter. And so let's go out here 30 to 40 foot. 40 foot's a good distance. And once you get about 40 foot away, you'll be able to see if you picked up a signal. So now we're about 35 foot away here, 40 foot away, and I'm on peak mode. I'm just looking for my highest response on the screen, and you can see as my numbers go up and down, it's telling me if I'm getting closer or further away. So my highest response is right about there, and there's my depth reading, 4 foot deep, and there's my current measurement. You notice we're not going to get as much current as we got when we hooked up direct, but we still got plenty. We got over 1 milliamp. As long as you got over a milliamp, you're going to get pretty good signal. And then to be able to tell if you're picking up the cable or pipe underneath you, all you have to do is just lift up the receiver in peak mode, and you'll see the numbers go down and the bar graph go down. If they go down, that means you're getting further away from the cable or pipe underneath you. If they go up, that means you're probably picking up the transmitter that's in front of you down there. So we got a good locate on this, and we'll go ahead and turn around and locate away from the transmitter as far as we can go. And then once we run out of signal, we'll move the transmitter closer to where we need to locate and continue our locate. But induction mode also works pretty well using a sweep function, the generalized sweep function. So if we had no idea where this cable or pipe is, what we're going to do, Brent's going to grab the transmitter now, and we're going to perform what they call a inductive sweep. And so we typically will walk away from the area and start out here, and what we're going to do, you want to come this way, Brent, on this side of the truck? Okay. So we stay about 30 foot away from each other. I'm on peak mode still. He's right over there, about 30 foot away, and we're going to walk together. And so as I'm moving, he's moving, and when we get over the top of a conductive source, like a cable or pipe, I'm going to see my signal go up, and there it's starting to climb. We got 8%, 10, 12, 15, 20, 30, and then it starts to drop back down. So I'm like, oh, we passed it. Let's go back this way. Okay, and now I'm going to find it. I'm going to see where I get my highest number, and I'm going to stop for a second, and I'm going to do what they call a reverse locator, or what I like to call a reverse locator. I'm going to direct Brent to go left and right and see my numbers go up and down as he's moving left and right, and I can tell when he's directly over the top of the utility by where I peak out. And so, Brent, go this way a little bit. I got 45%. Oh, it's dropping. Go back this way. 30s, 40, 46, up, 44, back this way, right where I had, right there, right, 47, right there. And now I know he's directly over the top of the line right there. And now that I know he's over the line, I'm going to go ahead and find the line too. So I move left and right, and looks like we are right here, right underneath this no parking, or this handicap parking sign, which they probably didn't call in a locate before they set. But we are 4 foot, about 4 foot 10 inches deep right there underneath that sign. So that's how you do a reverse locate. But that's induction, and induction works really well, especially with the radio detection unit. It's a pretty powerful transmitter. So if you need to induce onto something that's not carrying your current very far, directly hooking up, induction's a great alternative. You just have to make sure you use the right frequency. Go ahead and try 8 kilohertz, 33 kilohertz, 65 kilohertz, and then see how far you can take your locate. And then just keep moving the transmitter closer to your receiver, as long as that transmitter's staying outside that 30, 40 foot area. You should be fine. Your current, watch your current, make sure your current's at least over a milliamp. You can go ahead and take it lower than a milliamp and get a good locate, but that's when you notice your depth readings start to get sporadic. And typically, if I get about 50 foot away from the transmitter, that's where I see my depth readings turning out to be the best. It's not going to be nearly as accurate as hooking up direct, or maybe even using the ring clamp, but it's still a good alternative for when you don't have access to places to hook up, and or you just have no idea where the line lays. And because it's not picking up passively, or you have nothing to hook to. So that's an induction mode. And so let's go back inside. Okay, we're back inside, ready to go over the receiver. We need to be able to pick up that transmitted signal with something, and so the receiver is what you use to receive the signal, the frequency that you're pushing out. So we'll go over the battery tray, buttons, and the 3 things you need to remember on a receiver: where to set your frequency, the gain level, and the antenna configuration. And then how do we receive the signal? How do we confirm our locate for accuracy? And then passive locating using power, radio, and CPS mode. So let's continue. So the batteries, you normally get 2 D-cell batteries with the receiver, alkaline batteries. Make sure you're using good Duracell Energizer name brand batteries. These are Duracell Pro cells that are in there right now. And if you went ahead and splurged a little bit and got the lithium ion, good job, because the lithium ion is a great option on the radio detection receiver. It makes the battery life last 40, 50 plus hours. You hardly remember the things running off of batteries, and then you can easily quickly recharge it. And so if you want to replace that with the lithium ion, you can simply push in on the hinges. They give you instructions if you got the lithium ion battery pack to figure out how to do that, and you can move them back and forth between using alkalines and lithiums. And so what we have here is our on-off key. easily toggles it on and off. Hold it down for 2 seconds to turn the unit off. If you push it real fast while it's on, it goes into the menu function where you can control things you don't use very often. And we do have a full video on that. If you go into our video library, you'll find all kinds of videos on different options and different antenna configurations and stuff that we have if you want to find out more on any of this stuff. So frequency. We have a whole video on frequencies and what frequencies do in our YouTube library, but we'll go over that. But that controls your frequency and what channel you want to use. You know, just like toggling through channels on your TV, you have your different channels or frequencies on the locator. Up, down arrows to control your gain level, sensitivity level of the antennas, and the antennas are controlled by that button right there. That picks your antenna configuration for you, depending on what you prefer and what kind of accuracy you want. And so we'll go over those next. So settings, frequency, gain, antenna configuration. And so let's cover it. We have active and we have passive locating, just like we talked about with the transmitter. When you actively locate, you're hooking up the transmitter. Passively locating, you're actually just picking up power or radio, whatever frequency is already there. And so active locating is always the best choice. And to actively locate, the first thing you want to do is pick a frequency. What frequency do you want to use? We're on 512 hertz right now, and that's a good one. The lower the frequency, the less bleed off you'll get on everything that's around you, and the further distance you'll get. As long as you got good continuity on that line, 512 is usually a pretty good choice, and that's the lowest frequency found on the 7100 series locator. You have some lower ones on the 8100 series, but for the 7100, the 512 it's a good frequency to use. And if that doesn't work, you bump it up to the next one, 8 kilohertz. And then up from there is 33 kilohertz, 65, and if you have a TL model, you'll get into a 131 kilohertz, but your main three frequencies are 512, 8, 33. Those are the ones you want to concentrate on.
One of the keys to getting a good signal is applying the proper frequency. If conditions are good conductor, connections, and soil conditions, the current will travel farther at the lowest frequency, with less leakage to adjacent structures. An increase in frequency will cause the signal to leak sooner and cover less distance. As a rule, always start with the lowest frequency possible and increase as needed. And remember, at higher frequencies, the current will leak to the ground quicker, which may impact your ability to accurately locate. By contrast, poor conditions, poor conductor, corrosion, non-conductive joints, etc., necessitate the use of higher frequencies to overcome potential obstacles.
So frequencies, all right, 512, 640, 8, 33, 65, 83, 131, and the passive frequencies are what come on the 7100 series locator, depending on which model you have. All of them have 512 except for the SL model, but that's your lowest frequency. So when we talk about low, medium, and high, like in that video, 512 is low, 8 kilohertz is medium, and then 33 kilohertz or 65 would be your high frequency. You want to stay as low as you can, whenever you can, because that will allow your signal to go far, just like a laser beam. And however, when you're trying to illuminate more than just a straight line, maybe going up services or laterals, you have to use probably 8 kilohertz, which is more like a flashlight. It illuminates more of the whole room. So a really high frequency would be a light bulb. I mean, it just illuminates everything. So you want to stay away from those high frequencies, especially when you're in a congested area, because you will more than likely mislocate. You'll locate a copper service, water service when you're trying to locate gas or what have you. But stuff with good conductivity, like a coax cable there, or a copper pipe, low frequencies will work just fine. But when you're trying to deal with ductile or cast, you're going to need to go a little higher. 8 kilohertz usually works pretty good. And then induction, when you're using the induction method, use a high frequency. Or if you're trying to go to a dead end, use a higher frequency. So like in this example here, we're hooked on using 100 milliamps. And then that 100 milliamps is going down the service. And as you can see here, you get to the side, you got 60 milliamps going one way, 80 or 40 milliamps going the other way. But when it deals with that dead end over here, you can see nothing's on that going to the dead end using 512 hertz. I go a little higher to 8 kilohertz. Now we get a little bit of signal going down that line. And I go a little bit higher. 83 kilohertz goes to the end of that line, goes to the dead end. But it also illuminates everything else out there. So if there's other utilities in the area, you're going to have a little bit of trouble because you're going to get multiple magnetic fields being picked up by the receiver, and that's what causes mislocates. We have whole videos on frequencies as well. So antennas, if you want to find out more, about frequencies, we got a complete videos on it. Go to the video library. Go ahead and hit subscribe for any of our new videos coming out. We'll give you some kind of alert on your phone to let you know when we have more videos coming out on 8100 series and how to generally just locate. So antennas. Let's get into antennas. There's 5 inside the radio detection receiver. Ferrite rods, basically honing in that magnetic field to some metal windings, copper windings, and that's what it looks like inside the receiver in that picture. And so we choose what antenna configuration we want by that button right there. So the antenna icon is up in there, and right now we're in guidance mode. By pushing that button, we can go ahead and toggle between the different antenna configurations, which will affect where we end up locating if our magnetic field isn't perfectly round like in the picture here. And so if our magnetic field isn't perfectly round, we're going to end up mislocating. We're going to end up locating in a different spot depending on what antenna configuration you're using. And so when you're using all 5 antennas, you're actually using peak plus mode. And so that's actually a good locate method because you're actually using 2 different locators in one, sort of. You're using vertical and horizontal antennas simultaneously to let you know if you got the right signal or not. We have, again, a whole video on antenna configurations if you want to find out more. But the radio detection locator basically has 5 different options inside of it. You may not have all of them present on your model. Only a couple of them have all 5 available. But for the most part, the first one, peak mode, dual peak mode, it's a big hill icon. And then you have guidance mode, single peak mode, there's guidance mode there. But the dual peak mode, the big hill icon, is the one that's the most popular. And so that's the most accurate out of all of them. And then you have peak plus, and then you have null mode, and then broad peak and guidance. So right now we're in dual peak mode. Wherever you get the highest reaction is when you're over the line. And you can see that little tick mark that shows up there. When it peaks out, that tick mark will show up letting you know that you hit your highest response. And then peak plus adds arrows, and so that's what that little icon there looks like. And then that actually uses all 4 of those antennas to let you know when you're over the top of the line or not, and adds the arrows. They're kind of distance arrows too. They get smaller as you get closer to it. By holding down on the peak null button when you're in that mode, it will actually toggle you between regular null mode and peak plus null arrows. And so the peak plus null arrows are using the guidance arrows, which are a lot more accurate. And so you just hold down on that for 2 seconds, and you'll see the word null show up on the screen. It's kind of in the way there. And then you hold on to it for another 2 seconds, and it will go back to peak plus arrows. And then you got null mode. And so, sorry I keep getting in the way there. So the null mode just is the vertical antennas, and the vertical antennas basically null out when you're over the top of it. And then you have guidance mode, which does the same thing. Guidance mode is a really nice feature, and the guidance mode controls the sensitivity level for you. All you have to do is follow the arrows, and then that little shadow icon on the top there emulates the cable or the pipe you're locating. So when that's at the center of the screen, you're over the top of it. So when the arrows are both lined up and that shadow effect is at the center of the screen and the numbers are at their highest, you're over the line. And everything's pretty much automatic in guidance mode. It's a great mode to get used to the locator with. No matter which mode you're using, it's always using the peak mode to give us the depth reading. It's using 2 horizontal antennas to give us the depth, and depth is always to the center of the magnetic field. And some people say, hey, my depth's always reading to the bottom of the pipe or the top of the pipe, but it's not. It's always looking for the center of the magnetic field. So if your depth is reading to the top or the bottom, it's probably because your locator possibly it's miscalibrated, or it's possibly you're just not following the right antenna configuration. Go to dual peak mode, see where you get your locate, and if you end up moving over a little bit, it's probably because your magnetic field is distorted. And so gain control, where do we start our gain? Right now it looks like it's at a 97 percentile range. Those up down arrows, they'll control your gain levels. We want to start around 60%, 70%, and then when we get closer to the line and your numbers in the middle of the screen, the signal strength is at 99.9, you just hit the down arrow, it will self-adjust. If you're in guidance mode, it will do it by itself. You don't have to hit the up-down arrows. But use the gain control to kind of hone in your signal and turn it down enough so you don't pick up everything else that's around you. Again, it gets really congested out there, so the whole idea is to choose the right frequency, adjust your gain so it's turned down some where you're not opening up the antenna sensitivity too much, and then pick the right antenna configuration. Dual peak mode, or at least peak plus, those work really well, and if all else, guidance mode works pretty good as well. So let's go out to the field, and we are going to go apply these methods, all these different options, showing you with the receiver hands-on. All right, antenna configurations. I'll demonstrate this really quickly for you. And so we're going to go ahead and I'll turn on the transmitter again. I'll just go to 512 hertz here on my transmitter. Hit the F key for frequency to change it to 512 if you're not already on it. So there's 512. Make sure you got milliamps being displayed there. You can see as long as I got milliamps, I got current going out on that line. I'll go ahead and match it up again on the receiver to 512. And so hit the F key on here till you get to 512, and then here's your antennas over here on the right side. So that button there will switch you between the different antenna selections. There's null mode, there's guidance mode, there's the dual peak mode, and then there's peak plus. And so those are the different ones we talked about inside the office. The main ones that I'm going to concentrate on is dual peak, peak plus, and guidance mode. And so you won't find the null mode and the single peak mode inside the DL series. This is a PL, so this is, let me go to dual peak first. So the big hill icon's your dual peak, and all you're doing, again, just like the video showed, you're looking for your highest response. That little tick mark showing you where you got your highest response, and right there is where she's at. Get your depth, get your current, and then if I go to peak plus, it adds the arrows, and they're kind of distance arrows. They get smaller as you get closer to it. And right there again is where it's at. Where it peaks out on the bar graph up here is all determined by your gain level over here, your sensitivity. So if I make those antennas more sensitive by hitting the up arrow here, you can see it will peak out at 99.9, but you don't want that. You don't want to hit 99.9 because that's as high as the scale goes. So by pushing it down once, it will automatically adjust to where it needs to go. And now you can see it peaks out at around 40s, 50 percentile range. And again, if you're too low, let me turn it way down. All you got to do is hit it up once and it will self-adjust to where it needs to go. So the gain is semi-automatic. And when you're in guidance mode, the next one, let me go to that one there, that icon there. Now the gain is fully automatic. All you have to do is, again, follow the arrows left and right. And then you got that shadow effect like we talked about, and look for your highest number. And that's as simple as that. Just pick which antenna mode you prefer. I prefer the peak plus the most because I like to hear the noise when I'm over the line and don't hear it when I'm not over the line. And then the guidance mode is kind of the direct opposite. It nulls out if you're perfectly over the line. You get nothing. And then you get beeping on the right, solid tone on the left, and all you have to do is line up that little shadow effect in the center of the screen, and that's letting you know that we're on it. And just line up your handle with the compass, which we'll go over here in just a minute. But again, if you want to find out any more about all these antenna modes, consult our video on YouTube. It goes over antenna modes completely and lets you know the differences, because it explains completely about the antenna board, which I had here. There it is, Brent has it. All right, so the antenna board, this is what the antennas look like inside of here. And so the peak is using the bottom antenna and the top antenna. That's the dual peak mode. Single peak mode, just the bottom antenna closest to the ground. That's what makes it pretty good. And then the guidance mode is using all four of these antennas. So the dual vertical, dual horizontal, and then regular just single null mode is using a single vertical antenna. So that's why guidance mode and dual peak mode and peak plus are better, because they're using dual antennas. Our guidance mode, which is using all four of them. Actually guidance mode is using these two, Peak Plus is using all 4 of them, and so with the arrows telling you go left and right are using the 2 vertical. The peak response, the numbers, are using the 2 horizontal antennas on top of it. That's why I like the Peak Plus mode the best, because you're verifying your locate by watching the arrows and the numbers simultaneously. If they're in the same spot, you know you got a good locate. It's when they differ, you know you got a bad magnetic field caused by distortion. You got destructive or constructive interference going on, so you need to change frequencies, move your ground, move your hookup, do something to make it clear up. So let's go back inside and continue on. All right, back inside, covering our last section. How do we check our locate for accuracy? Remember the 5 antennas I was talking about when we really only covered 4? There's a 5th one, and that's the compass antenna. So the compass is actually, you get to the other side here, the compass is the center antenna, and it's actually telling you which way your magnetic field is facing. And so if your magnetic field starts to distort to the left or to the right, the compass will go crooked. If you're trying to locate an elbow, you'll see the compass kind of follow you through the elbow. It's a nice tool to guide you through where your magnetic field is headed. And then we have the peak, we have the depth, and then we have the current measurement. So peak and null we covered already with the different antenna configurations. As long as you're going through your different antennas and they're saying it's in the same spot, you probably got a good locate. If your compass is straight, you probably got a good locate. If your depth reading is correct, you probably got a good locate. The easiest way to tell if the depth's correct is put the locator on the ground, take a depth, see what the depth is on there, and then pick it up off the ground exactly a foot. It should add a foot to your depth reading. If it doesn't add exactly 12 inches and it's adding 14 or 18, it's because you have a distorted magnetic field. It can't calculate it correctly. So just do that quick electronic probing is what I call it, doing a quick depth check that way. You can also verify the depths to the left and the right, and we have more videos on that if you want to check out our video library. And then current measurement. Current measurement is a good one, and that's just as important as a depth reading. Your transmitter tells you how much power it's pushing out, how many milliamps it's pushing out. In this case, we're pushing out 20. The receiver will tell you how many it's picking up. And so 100 milliamps we're pushing out there, we're picking up, what does it say, 47. We're picking up half of what we're pushing out. It should be pretty close. I mean, you're going to lose some at your hookup. As soon as you start your locate, you know your current's dissipating constantly as it's moving down that line, and it's going to dissipate a little faster at the beginning where the ground rod is closer. But whatever line you're picking up, especially if you're picking up multiple, the line that has the most current on it is the one that you probably want to paint and flag. That's your target line. And so current measurement it doesn't have a lot to do with the depth. I mean, if you have a line that's deeper than the other one, your signal strength will be lower. The numbers on the center of your screen will be higher, possibly on a shallow cable TV line, like in this case 8 inches deep. But if you are over your target line and read your current, you should see more current on your target line, and that will help differentiate between what's not yours and what is yours. And so that's how we know what our target line is. On the 8100 series, we get into current direction, which is nice as well. And then some specialty products from Radiodetection will give other confirmations. But on the 7100, you have current measurement, you have peak and null, you have depth reading, you have a compass, all to let you know if you're on the right line or not. And so use those religiously. And let's go outside and apply this. Okay, so compass and current, two good ways to determine if you have the right locate or not. So we have the peak and null, the arrows and the numbers should be in the same spot. That confirms we got a good locate, like in this example here. Peak is right there, arrows say it's right there, it's probably a good locate. You again can use your depth reading as also a way to confirm by just lifting it. You should see the depth go higher and higher. If you go exactly a foot high, it should add exactly a foot to your depth reading. So right here on the bar graph of the Radiodetection is about a foot high. So if I hold my finger there and lift it, it should add exactly a foot to the depth reading. But what we want to talk about is compass. Compass is orientating the direction of the magnetic field, letting you know which way your magnetic field's headed or your cable or pipe's headed. And so if you get to a turn, it's going to turn as well. But if your compass, if you're not lined up correctly with what you're locating, you notice your depth reading will disappear. It knows it's not going to calculate it right if you're not perfectly perpendicular to the cable or pipe. And then your current is measuring the amount of current coming from the transmitter. If you remember, we were pushing out about 10 milliamps from the transmitter. Well, we're picking up about 80% of that, 8.42 milliamps. That's cluing us in that we're on the right line. We're on the target line we're looking for. So that's a good indication on how far you can go on your locate too. Once that current is down to about 1 milliamp, you want to think about probably moving your transmitter closer to where you're locating, increasing the output maybe. So that's when your sensitivity gets too high. You know, when you're losing current, you got to control your sensitivity, turn it up to compensate for what you're losing. But then you can only go so far before you start possibly picking up other lines. You don't want to turn your sensitivity up too high. You'll start opening yourself up to interference problems. So let's go back inside. All right, last thing, passive locating, power mode, radio mode, CPS mode. And so I'm getting exhausted here, but we'll go over this one last thing and then we're done. I appreciate your time, your patience. Again, if you haven't subscribed yet, subscribe to our page there and get notifications when new videos are coming out. And go ahead and like us too. It helps our algorithms, helps bring this video up for others to learn. And I love educating on line locating. It's all about damage prevention and keeping everybody safe out there. So passive locating, we all know it. A lot of guys like to passively locate using power mode. They end up using power mode a little too much. It does serve a purpose though. I mean, power mode is good. But what we're doing when we're passively locating is just going off the live energy that's already present on the utility. And so power is picking up 60 cycles, it's picking up 60 hertz, but not all power lines are 60 hertz. When it's a two-phase or a three-phase primary line, you'd be 60 plus 60 plus 60. It's really 180 hertz. And so you kind of have to know what power or what 60 hertz cycle that power is picking up in order for power mode to work. And so let's go over this video real quick about power and passive.
Passive locating is the act of finding cables that already have a circulating current, such as buried power lines. The cable must be energized with a network distribution electrical current at a frequency of 60 or 50 hertz, depending on the part of the world in which you live. The passive method will not work if the power is off. Likewise, the intensity of the current circulating depends very much on the load. For example, running your house air conditioner versus charging your cell phone. One requires a lot more current than the other. Therefore, passive locating must be used with caution, and only when other methods are not possible.
All right, that's a good explanation on how power works by Sondes, our friends at Sondes. Great videos again. Thank you for that, Sondes. So you have power, you have radio. Power is the most popular. It picks up the 60 cycle. Again, if no current's going down that line, power's not going to work. But you can hone in on that power depending on what type of power line it is will determine if it's 60, 180, and the PL model has power filters. That's what makes the PL different than the DL and the others. The DL just is a generalized power mode. It will pick up any frequency as long as the variable is 60 hertz. from 60 on up to 1 kilohertz, it will pick up that power line or whatever else is that line is. Almost everything metallic out there has some power on it, and so the power mode is kind of a safety function. If you plan on putting your ground rod in the ground before you're doing your locate, you want to scan the area and power and radio to make sure there's no utility there. Do a passive sweep and make sure that there's nothing there. But the power is also a good way to, after you're done with your locate, to see if there's anything else that you're picking up that has not been located by actively locating. And so the other one is the radio mode. Radio mode sounds like a staticky radio station. It will pick up anything that has some radio signal on it. All radio signals out there in the atmosphere between 15 kilohertz and 29 kilohertz. You got a lot of different frequencies out there being pushed by satellite signals, TV stations, radio stations. Those signals are bouncing off of everything metallic, and everything metallic is reflecting some of that radio signal. So in radio mode, you'll pick up things that you normally can't just see, but you'll pick up a lot of things using radio mode, but you don't know exactly what it is. It's just a reflection. You won't be able to get a depth reading on it, but it is a good safety feature. Again, a passive sweep function that you can utilize. But the one that's real popular is CPS mode. CPS mode stands for Cathodic Protection System mode, and that will pick up rectified current. If you have, if it's a gas company with rectified current on their gas lines, you can use that rectifier as your transmitter source. And it's actually 120 hertz, and it will pick up that CPS mode, Cathodic Protection System mode, and you'll be able to line locate, just like if you're hooking up with a transmitter on 120 hertz, you'll be able to get your depth readings, your left-right guidance arrows, your compass, and everything. So CPS mode is a great tool, but again, actively locating, hooking up direct is always the best way to locate. You get the most power on your line, and you're able to isolate it best using your identifying frequency that you're placing on the line with your transmitter. So let's go back outside and apply the passive frequencies. All right, so we're back outside. We're going to use the passive frequencies, and the first one is power mode. That's found on all the different receivers. It's your safety mode for scanning for live power lines. It's picking up a variable of 60 hertz, no matter if it's 60, 120, 180. So generalized power mode in a DL series receiver will not give you a depth reading, but it will tell you where it's at. So you can see it's just like a peak response. It's just telling you to go left and right, or it's giving you a bar graph response, a tick mark, telling you where it gets highest response. But that's power mode in the DL. Again, it will not give you a depth reading, but boop, if we bounce it out for a PL model, it will give you a depth reading. So the PL model will give you a depth, and it also does fault locating. So that's the benefit of having a PL model. So there we are on power mode, and as you can see now I get a depth. And the nice thing about the PL model is it has the power filters. So I can go, if I know I'm looking for a single phase primary, I can just hit the antenna button there once, and now I'm in straight 60 cycle. And now I got arrows telling me to go left and right, and the compass, just like I'm hooking up with the transmitter. And there's my depth. And now if I knew I was on a 3-phase primary, I can hit that filter button again, the antenna button, and now I'm in the straight 180. And if you know you're on a 3-phase, that usually will give you a little bit more accurate depth reading and a little bit more accurate locate. As you can see, we're a little bit further this way now. But it also goes to 300, it goes to 420. You just kind of scroll through there and see which one is possibly giving you the most signal, the best signal, and the most accurate depth, or the most logical depth reading. But what the PL does not have for passive frequencies is a CPS mode, but it does have radio mode. They both have radio mode. There we go, there's radio on that one. And radio mode is a generalized passive frequency that, it's just picking up the stray radio currents, radio signals like we were talking about. And you can hear the reflection coming off that power cable, but you won't get a depth reading in this mode. But on CPS mode, that stands for Cathodic Protection System mode, you can see it's trying to pick up this power right now. It's actually picking up 60 hertz off the line a little bit, since it's looking for 120. But it's anything that's rectified, any power or any gas line that's rectified, has rectified current protecting it, such as mainly in transmission lines, you're able to use that rectifier as your transmitter source. And that's what it's doing right now, is picking up the milliamp reading from a rectifier, and a depth reading, even though we're on a power line. But you get the idea. So that's the DL model. That has CPS mode on it, whereas the other ones don't. So that's the benefit of a DL over a PL, is you can use it for gas, locating gas without using a transmitter. Whereas the PL for power is meant for power locating. So let's go back inside.
Hi, I'm Brent. I'm out here just helping to answer some of the questions while Travis takes a quick break. But just going through some of these questions that we've had from YouTube, I thought I would just try to answer some of these questions. We've been plugging away, kind of trying to answer them just via the text chat. But one of the first questions was single phase and three phase power locating, and just the different ways that we might want to locate. One thing to keep in mind is you always want to try to locate back to your source, back to where there's a lot of ground. So whenever you're on like a single phase, wherever that mass of the system is, it's usually easier to hook up and locate back to it. The other thing to watch for is when we are on the power, just locating on the passive mode, we can use 60 Hertz. That works really well on single phase lines. And then we can use the 180 Hertz when we're on a three phase. Now you will notice sometimes, especially when we're closer to substations or something, we can get a lot of harmonics that can also help you isolate your line. Like if you ever have out of a switch gear, a three phase right here and a three phase over here, sometimes we'll find that maybe this one has a good 300 Hertz and maybe this one over here has a good 540 Hertz. That can help us start to be able to see where exactly that's at. And then we have a question about irrigation wire. You know, I think high frequencies can be really helpful with those because they don't have your traditional grounding system that you have on power lines. Usually you want to hook up to the white wire. That's your common, because that feeds to any valve boxes that are around. 65 kilohertz, 33, 8K, or even a 5100 is a good option, the 83 kilohertz on that. You don't need a lot of power. They're good conductors. Also, check out our website. If you go to subsurfacesolutions.com, you can go up to the menu and you can see training, and you can go down and you can look at manuals. And there's tons of manuals for 7100, 8100, 5100, anything that's out there. So that's available for you to be able to download.
Yeah.
So, yeah.
Is that all the questions?
We got a couple. We got using induction on street lights. I don't have a street light right here.
Yeah, well, no street lights in this parking lot. But
usually,
this tracer wire might be.
Yeah, we could probably do something here.
So if you have a dead-end street light like this, a last street light on a series like this, you can try to induce into it. As it's really difficult because, of course, like the video was saying, that you don't have a conductor for that signal to go to. On, you know, it's trying to complete the circuit on both sides of that wire or whatever line you're going over to. So I'm going to go ahead and set this here, and if you can ground that wire, that would be great. But say we can't get to it, we can't ground it, we can't get in the pole, I'm just going to turn this transmitter on and I'm going to push it up to the highest frequency that's in here, and we are going to go ahead and go to 65 kilohertz right there. And so we're at 65, say that's the highest since we have only a DL, and I'm going to turn up my power all the way to 100%, and we're going to try to get anything to jump across onto this wire. So Brent's out there, he's in front of us, and he's on 65. You got it?
Yeah, so you could do something like this around the
Yeah, you can do something like this if you know, and see if you get anything. Just make sure that you're getting out far enough away from the transmitter, probably at least 30 or 40 feet, so you know you're not just picking up signal off the transmitter. But if you have the TL model, you're going to have some higher frequencies like a 131 kilohertz, or you can just go ahead and splurge and get up to the RD7100, where you have all the frequencies and all the options that Radiodetection has on their units. And like Brent was saying, make sure that you check out our videos, our other videos that are on our YouTube page or our website. We have lots of different training videos you can go back to, and this will be posted too when we're done. And so, do you have any other questions that came through?
No, I guess one extra comment. Tim, he made a good comment that a lot of times you can use power mode also on the street lights.
Yep,
You'll
as long
definitely
as you-
notice that as it gets darker or
Yep.
earlier, but if there's a load on it, it's worth checking.
Yep.
Last question, best way to locate gas?
Okay, I'm gonna run back inside and get
Okay.
ready to close this thing out.
That sounds good. So, you know, we've talked about all these different methods, ring clamp, direct connect, induction, different frequencies. Gas is a pretty good system to locate generally because usually it's all welded together. Maybe you might have a dresser coupling in some spot. You also have insulated service lines, but generally speaking, you could just use direct connect. It's a good system for it. It's an isolated system. So you just want to get your ground rod out, make sure you get it away from any other utilities and away from where you want to locate, and direct connect to say whatever it might be, a tracer wire, or you know, just right at the service if it's all steel, and follow it out on a low frequency like 512 hertz. It's going to tell you where it's wanting to go to.
Quickly go through the difference between the 7100 and 8100. What you get with the 8100?
So, new question. So, some differences between the 7100 and 8100. I like to think of the 8100 as the thing that everything's built around. It's this top of the line model. It has the same antennas between the two different locators, but the 8100 has like 40 some frequencies, a lot of more customization options there, and those frequencies can be really helpful, but it also has sonde locating, fault locating, basically everything that you need. So it's specific to any industry. There are other cool things that you can do with it is you can Bluetooth, you can change, we've got close to a half mile away, but technically about a quarter mile away, we can change the frequency on the transmitter so that we can work through a troubleshoot. Or one of the things with gas that I like to do is I like to use a low frequency on the mains. We're going to pick up less of the other lines, and then if I need to pick up some services, I can try to pick some up with a high frequency, and you can change it. So that's a really helpful feature. The other cool thing is you can actually pair it via Bluetooth to like a GPS unit and a tablet. We do a lot of that. So those are your big differences. I would say 8100 is more of your expert option. You're going to be able to do anything with it. The 7100, that's just for keeping it a little bit simpler, but it still gives you all the flexibility and the same locatability. And I guess I think it's time to transition back inside.
All right, we are back one last time. What accessories do you need with your locator? We're in the home stretch. Fault locating is a nice one. It adds the A-frame to the TL and the PL model. It allows you to find cable faults. Stethoscope is basically to look for wires and pipes or whatever in a wall or maybe in a pedestal that plugs into the front of the receiver. Sondes are a nice feature. We covered that a little earlier, a little bit. A battery operated transmitter you can push down through empty conduit and trace it as it's moving along, and the DL model is a good model for that. You have the marker ball locator. You can get each one of these models with a flip down marker antenna, and looks for the plastic marker balls that are buried, and a lot of companies are gone to using some marker balls to identify stuff that's not locatable. And so the last option, let's see what other options are there. Of course, we covered the ring clamp. We have underwater antennas. There's a lot of miscellaneous other options on there as well, but depending on what you're doing, if you want to do fault locating, that's a great option. I mean, if you're doing any kind of power or telephone, the fault locate capabilities is really nice. Take care of your locator. Treat it well. Don't run it over with a track hoe or your truck. If you get angry at it, call the locator machine suicide hotline, which is my number, and let me know. Give me your deepest thoughts about how your locator's mislocating and this and that, and we'll walk through it over the phone, and I'll talk you down a little bit off of your ledge and say, hey, it might not be the machine, it might be how you're using the machine. Let's go over the different options. Let's do the antenna configurations, frequency, what scenario are you in? Everybody that works at Subsurface Solutions, we were locators. We were in the field doing 100 tickets a day. It seemed like many days. There was several days I did quite a few tickets. We know what you're up against. We know you need to get locates done. Your bosses are pushing you to get as many done as possible, but you also need to be accurate. And so the workflow is not always the easiest, but and some mislocates happen, they do, but there's always a learning experience involved in each one of those. And so let us go ahead and go over that with you. If you got questions, again, throw your comments down over there. If we don't get to you by the time we're done here, we'll try to respond to as many as we can with replies, but we're always here. Our website, subsurfacesolutions.com, we can help you anytime. So again, keep care of your locator, take good care of it, keep it out of submerging it in the water. It will work in the rain, but it's IP67 rated, but it means it will go through a car wash, but you don't want to submerge it. You don't want to leave it in the back of your truck in a downpour and let water fill up inside the case. You don't want to put it behind the exhaust of a generator for 2 hours while it's getting hot. That's what happened there. Nicely melted. Somebody made some s'mores out of it. And if you're using bug spray, don't use the bug spray around the screen of the locator. Keep it clean. You get battery acid leak inside the locator. Make sure that you get it cleaned out right away. You neutralize it, get it out of there. Battery acid is the #1 thing that hurts locators. #2 would be water, getting water inside of it. These are really well sealed up, but if you submerge it or let water rain on it constantly overnight, I mean, obviously you're going to get moisture inside of it, and that's going to break down the electronics on the inside. Make sure you're not hooking up to live lines unless you have the live wire connector, another accessory I failed to mention. But again, all the radio detection stuff pushes out 30 volts as a default, and then it will go up to 90 when you switch it to 90 in the menu system of the transmitter. But it stays at a safe level of 30 volts all the time, because if you get up to 50 volts, you can actually kill a person. So OSHA requirements are requiring us to stay down to 30 volts. Below 50 is an OSHA requirement. And so that's why it starts off at 30 and then goes up when you purposely go in there and move it on up. So don't hook up to live lines unless you have some kind of protection for the locator and yourself. You know, use the proper case. Don't try to clean it with graffiti off or any abrasive cleaners. Just take good care of it. They last a long time as long as you take care of them. And then the biggest thing again is mosquito spray. It will make that screen probably fog over if you get it too close. Something with a lot of DEET in it, it will make it fog over. There is a test function inside all the radio detection units. You know, if you want to tell if the unit's calibrated, if you think it's out of calibration, the first thing you want to do is run the self-test. Go into the menu system by hitting the on-off key real quick and scroll through it by the up-down arrows. And then when you see the info area, they go into that and by hitting the peak and null button. And then scroll up or down until you get to test. When you get to test, go ahead and run the test by hitting the peak null button, or antenna mode again. And it will go through and test the minor calibrations of the machine, and then make sure you're in a remote area when you do this. And if it comes back and passes the test, it will say PASS. It takes about 30 seconds. But if it fails, get to a more remote area, get away from your tailgate of your truck or something, and run the test again. Make sure your transmitter's not on, and it will test it again. And if it keeps repeating a fail, there's possibly something wrong with it. That's the nice thing about the radio detection, is if it passes that test, it's probably good. It's probably fine. It doesn't need to go in. It could just be because you got a bad magnetic field or the way you're applying your current. And so run that test. That's a self-test in the locator. Lastly, what causes a bad locate? Now that we know we are locating magnetic fields and not cables and pipes, what causes a bad locate? Distortion. I heard you. I heard you in the back over there. Distortion, yes. Distorted magnetic fields, interfering magnetic fields, other magnetic fields in the area. You got magnetic fields everywhere. Destructive, constructive magnetic fields pushing each other around. You know, they're just like today's age. Everybody's pushing each other around. It's playing its politics. So how do we get away from that? Think about how you're going to ground, where we started this whole thing out. What are you going to use for a ground? Where are you going to place the ground? How's that return current going to get back there? How are we going to apply our signal? What are you going to hook onto? Or are we going to address it like putting a puzzle together where we take it from the outside back into the congested area? What frequency are we going to use? 512, 833, 65. Where should we start a power in the transmitter? Well, start off low and work your way up. You know, start off with 1 bar of output, 20 milliamps, 5 milliamps, depending on how far you're going, will kind of determine how far you need to turn that thing up. But don't overpower it. All it's going to do is cause you to bleed off more if you overpower a higher frequency, you know, trying to illuminate everything in the room, just like the light bulb. And then understand what's around you. Don't put your ground rod over the top of another utility line. Understand roughly how utilities run, where they should be running. You know, look for your visual clues on where that line is terminating or where it's headed. And then trust your locator. Get to know your locator. Get to know the antennas and what they're telling you, the information that's coming in, and confirm your locate by looking at the depth reading, look at the current measurement reading, look at the compass, and compare your antennas. And so that concludes our first live training. Yes, you made it through. I don't know how long it's been. It's been like 14 hours. I don't know. We've been working on this a long time, so I'm glad you showed up for our very first live event. Hopefully it went off without a hitch. I think it did. I'm not sure. I'll talk to my staff after we're done here. But hopefully you enjoyed it. This will be posted on our YouTube page, so you can reference it at any time. Again, if you have questions, feel free to go ahead and contact us or ask in the live chat area, and visit our website. Subscribe so you get notifications for future video trainings that we're going to be doing. We're going to be doing a lot more of these now that we kind of figured out the process. But again, thank you for joining us, and hopefully I taught you something here today about the RD7100 from Radiodetection.